Welcome, everyone. My name is John with Simwell. Thank you for joining Evaluating Onshoring and Nearshoring Strategies with Any Logistics. Our goal today is to show you how to evaluate supply chain design changes, and specifically, how to balance cost, service level, and risk in a supply chain model before making a change in the real world. After this webinar, you'll know how to create a baseline model of an existing supply chain and compare a few scenarios to answer the question, is onshoring worth it for us? But we won't just answer the question, is it worth it? We'll also make a plan on how to do it. This is a live webinar, so we encourage you to ask questions when you have them. You'll see a chat window that looks something like this picture. We have a team ready to respond to your questions as you ask them, although we may wait to respond to some of your questions until the end when we'll have a Q&A session. If you don't want to submit your question in the chat, you can contact me directly at simwell.io or email me at jsantavi@simwell.io. Today's webinar is hosted by Simwell, a consulting company specializing in simulation and optimization. We're also an Any Logistics distribution partner in North America. My name is John. I'm a partner at Simwell, and I specialize in helping companies answer their most critical what-if questions through simulation. I am joined by my colleague, Alex, a senior supply chain consultant at Simwell. Alex has a breadth of supply chain experience spanning 17 years, and he has a deep understanding of Any Logistics. Today, Alex will be walking you through a model of evaluating nearshoring and onshoring strategies for a company that manufactures overseas. So I want to start with defining onshoring, reshoring, nearshoring, and offshoring. So onshoring and reshoring are more or less the same thing. It's when you're manufacturing inside your company's primary country. The reshoring suggests that you've moved offshore and now you're coming back onshore, but more or less they're the same idea. Nearshoring is manufacturing outside but near your primary country or primary headquarters. So for example, I'm in the United States. If you look at this map, the nearshoring would be in Canada, Mexico, or the Caribbean, and very nearby countries. And offshoring is when you're manufacturing overseas. So if we look at this map, again, the onshoring are these gray locations, or at least for me, from my perspective in the United States. Nearshoring is Canada, Mexico, and the Caribbean, and offshoring is anywhere overseas or far away. Of course, from where you're located, it'll be the same idea. Now, before we move on, I want to emphasize that this webinar has a global audience. And nearshoring and onshoring is really a global topic. I'm based in the US, as I said, so I'll talk a lot from my point of view, but this really is a global topic. To show that, here's a couple of recent headlines from around the world. So from the UK, onshoring could be a rewarding post-pandemic strategy. From Australia, reshoring takes off as manufacturers risk-proof supply chains. From North America, 64% of manufacturers say reshoring is likely following the pandemic. And in Asia, Japan ditches China in a multi-billion-dollar coronavirus shakeout. So while I'll be talking a lot from my perspective and the models we'll be showing are from my perspective, this is a topic that companies are considering all around the globe for a lot of different reasons, and we'll go over some of those today. So onshoring and nearshoring and simply restructuring supply chains in general is something companies and governments are considering all over the world. But why now? Well, there's certainly some obvious recent triggers, but there's really a lot of reasons. The recent ones that we can easily call out are trade wars and tariffs, and of course the pandemic. But there's increasing natural disasters, intellectual property concerns, and rising labor costs in developing countries that are all triggers for this gathering around or interest in nearshoring and onshoring. And these triggers are all causing problems. Problems to the business and problems to the supply chain, like delays, border closures, shortages, disruptions, and additional costs that just were never planned for before. So you're probably thinking that these problems have happened before, and nearshoring and onshoring wasn't considered as widely as it is now. So why now? I believe that these triggers and problems are getting bigger, but the ability for companies to do something about it is getting greater as well. In other words, the benefits of onshoring and nearshoring are starting to outweigh the benefits of offshoring for some companies. Some of the reasons for that are that companies are placing higher value on things like agility, resiliency, visibility, quality control, transportation costs, and government incentives that are changing to focus on bringing operations into a company's main residence. So the question is, what do we do about it? For you, you're probably asking, is it worth it for my business? And how do I actually figure that out? The way to figure it out for your business is to figure out what's important to you and your customers. There's something I call the supply chain equation. In the past, it was based on cost plus service level. Now, due to the triggers we discussed on the last slide, like the pandemic and trade wars, and the problems those triggers are causing, like delays and shortages, there's a new variable in this equation, and it's risk. Companies are no longer focusing on lowest cost, they are considering risk and resiliency. So when you balance these correctly, you'll have the right supply chain design for your business. So let's go back to the question we're asking. Is it worth it to onshore or nearshore for my business? And that's a tough question to answer. There's no simple answer. So how do you go about answering it? Is it a spreadsheet? Well, that's how most companies work today, and it's a great tool, but it falls short in capturing the real-world complexity of a supply chain. So it falls short in answering real-world questions like, is it worth it to nearshore or onshore? So to answer that question, we use a combination of optimization and simulation. Optimization helps us find the best design, and simulation helps us to determine how it will perform in the real world. The tool we use to answer questions like this is AnyLogistics, because it can capture the real world complexity of the supply chain and help to answer complex supply chain questions. So now, in the scenario that we're going to walk through today, my colleague Alex is going to walk through. And we're all going to imagine that we're operating a global company that manufactures overseas. Due to the pandemic and trade wars, we're evaluating whether an onshoring strategy is right for us and how we can actually implement such a strategy. So, ideally, we could just know what we want to do and make a change in the real world. But we can't do that because this is an existing operation and it's too high of a risk and too costly to make changes that we don't know will work. So Alex is going to help us figure out what we should do. First, he's going to build a baseline model of the existing supply chain in AnyLogistics. Next, he'll evaluate a few scenarios and compare the KPIs and the P&L for every scenario so we can make a data-driven decision of the best way to operate. Finally, after we're confident in our risk-free analysis, we'll implement in the real world. So with that, I'll turn it over to Alex to show how to evaluate supply chain strategies with AnyLogistics.
Thank you, John. Thank you for that intro. So before we start up, everybody should be able to see my screen. You're going to be seeing an onshoring baseline model. And so you'll see here in Asia, we have our supplier and our port. Obviously, with volatile changes that have happened in the last few years from tariffs, the need to serve customers within 24 to 48 hours, border shutdowns, supply chain delays and storage shortages caused by production and logistical issues. We're going to look into what we can do to onshore that business, or in other words, our factory. So as you see, we do have a supplier and port here in Asia, and then we have our port here. So let me show you how that looks. Here's where we import our products into this port in Long Beach, California, and we're using 4 DCs, these icons in red, to distribute to the rest of the customers. We do have 3 types of customers in this model. We have regular stores or shops, mom and pop shops in blue. We have retail locations in red, and then we have wholesalers that are in brown. And obviously those have a higher amount of volume demand as they also distribute to other stores in their areas / regions. So what we're going to do is we're going to run this model just to show you an animation to see how everything moves around the animation and the supply chain. So let me open the screen up. So there you go. So as the animation goes, it gives you a little bit of a view of how all the product is going, and you get your quantifiable numbers here below. So what I'm going to do is I'm going to fast forward this animation just to complete it. I'm going to go ahead and just save the results, and while it's saving, I'm going to show you guys a bit of all the KPIs available. So that you understand the outcome of that. So currently, this is how well we're doing in our supply chain. And since we've taken this data from obviously your systems, this is basically currently should be identical to your P&L. So here's where we have your transportation costs, and let me sort this a bit. Here's your revenue, 62 million. Your total cost was close to 44 million. Inventory spend, how much you purchased in supplies. Profit, which is 18 million, that's really good. Transportation costs, and here are your tariffs, close to 4 million. Inventory carrying costs, facility costs, and other costs. And there's an array of KPIs like service level, how well we were providing to our customers, here's how well we're providing ELT service-wise from a transportation perspective, and if we had the inventory once the customer made the purchase. So we were doing really well. Here's lead time. Here's available inventory graphs. Fulfillment. I think this is great because you could see how many orders were dropped and how many products, how much was placed on each category type, or if you want to go to the customer level to identify which customers did not get their product on time. And we also have site capacity as well. This way you can identify how much the capacity is currently for each one of these sites. So for, let's say for New York, how much I would need of capacity, Los Angeles, and so forth. So really nice, interesting perspective of space and capacity. Okay, so now what we're gonna do is we're gonna go ahead and convert this into a GFA. And the reason why we're gonna do that is because we wanna find our factory here in the US. We're trying to get away from the factory across in Asia. So let's go ahead and create a copy of that. There you go. I'm ready to start looking for my locations. So in this design, we're gonna go ahead and first, let's go ahead and remove the suppliers and ports. So let's go ahead and remove this one for the time being. You could go ahead and you could do it 2 ways. You could exclude it, right? Or you could just go ahead, click on it and delete it if you're not going to use it. We're not going to use it anymore, specifically these, and we're not going to be using the port in the West. It's all, we're going to onshore everything. So So now that we've cleared that up from our design, we can start from fresh. We could delete, we're gonna also delete all the sourcing. This is basically how who can fulfill who, right? The supplier can fulfill the port fulfill the other port, and this port fulfill all this DC. So we don't need that anymore as well. So we're just gonna remove that, and we're gonna go ahead and add back just 4 connections. And these are basically our sourcing from our DCs, right? So DC Chicago is gonna satisfy all the customers in the Chicago customer group. Houston is going to do all the customers in the Houston group. So now we have a satisfied customers that are already kind of regulars for that DC, right? So he's going to go ahead and finish that up. And that's it. Now you have the connections required to run the GFA. It's that easy. So let's go ahead and run a few experiments now to find the best location for a factory. There's 2 ways to do this. We have a GFA experiment, which is like a crow view, and then we have a GFA with roads experiment. Both are great options. We're going to start with the GFA roads experiment. And here we have really 2 other different options, right? One where there's influence from the suppliers, and another one where there's no influence from the suppliers. So we're going to start with really no influence because we have no suppliers still on our map, as you see. So there's no suppliers here in green, right? So let's go ahead and select this. And what we're going to do is we're going to run it for one site. We're going to look for one site only, and we're going to set it up for 50% supplier, meaning that there is some influence, but obviously there's no suppliers right now, so there would be no influence. And we're going to set it up to 25,000, meaning we want the site to be placed in a location where there's enough population to support the DC, right? From a work perspective. So let's select this nice gold icon color for the factory. I think that satisfies that. And make sure we change from satisfying the factory satisfying the DCs, right? The factory's not going to satisfy the customer, it's going to satisfy the DCs. But obviously, if in your organization that's possible, then obviously you feel free to select that, right? So let's go ahead and run this model. And there you have it, our first result. As you take a look, this is considered most optimal in reference to no supplier influence. So from here, this factory to supply Chicago and the rest of the DCs in the US. Let's take a look at how that looks. So here's a nice view of it. It's the GFA, the most optimal would be here close to Chicago at Oak Forest. That's optimal location, and which DCs is satisfying. This is a great view of framework view of the model now. So let's go ahead and rename this. I'm going to rename it to as result for one plant, no suppliers, right? Excellent. All right, so let's go ahead and run that same one, but this time with 2. Now we're going to look for 2. It's still the same. We could maybe select piece to make it easier on our results. Again, still supporting the DCs and still the same color. That's great. So let's go ahead and run that model. And there you have it. So in this case, with no supplier influence, 2 sites, the best would be here, one in basically right on top of the other DC, so as close as possible to it. And on the West Coast, it would be very close to the other DC. So 2 optimal locations, and it would look like that. Let's rename this to 2 plant results. Suppliers. Great. All right, so now the second way to find a factory location is considering the suppliers. So let's start putting some suppliers up. Why would you use suppliers as an influence? Well, let's consider the options that in an organization, the suppliers have long contracts or they've been there for 10, 15 years. So the expectation is they're going to be around for a while. It's the main ingredients of your product, right? And so obviously you would want to have high influence or some certain influence with the supplier's location. But if let's just say these are suppliers that are on contracts for a year or 2 years, and they constantly are swapping because you have lots of thousands of products, obviously you want no influence, right? Because they're going to be always changing and it wouldn't matter as much. So just be clear of what the organization and your industry and how the contracts are established to be able to influence or not influence with suppliers. So let's go ahead and add 5 suppliers. Let me go to my data. Just start clicking a few locations. Let's build one in here close to Northern Ohio. Let's go build one in West Virginia and go Southern Illinois, maybe here, I don't know. And let's go build another one in North Carolina by Charlotte, right? And one more. Let's try Alabama, Montgomery. There we go. So now we have 5 suppliers, and let's go ahead and start looking to running this one model with the supplier influence. So let's start with one plant. We're looking for one plant optimal, and let's consider 50% influence from the suppliers now. All right, and let's leave it at 25. This is perfect. Pieces. Let's leave the new icon to go, and we're still servicing the DCs now. So this is perfect. Let's go ahead and run this model. Excellent, there we go. So with one plant, and a supplier, it shows this supplier. Let's see how they're connected. So it shows this location, Southern Illinois, and it shows this supplier in Southern Chicago, Illinois. So let's take a look at how that looks. Yeah, so it shows supplier 3, and then it created one in Carbondale to satisfy all the DCs. Optimal location, reference to also your supplier. All right, so this is interesting. So let's rename this just to remind ourselves what this result is. It's one plant with suppliers. Great. All right, and let's run another one here with 2 sites now. Similar, we're gonna go ahead and quickly run that. And now we have one here in Houston, right? Here's and another one in Sandusky. So Houston and Sandusky as optimal locations. Let's check how that looks. There we go. Okay, and so this one location is between Chicago and New York. It was identified as the optimal location to satisfy these 2 DCs, as you see. And it would satisfy New York, Chicago, and the Houston would satisfy Los Angeles and Houston DCs. So let me go ahead and rename this as 2 plants with supplier influence. Great. All right, so let's run another one though, just for fun here. Let's indicate that there is 100% influence. And actually, when we talk about 100%, we talk about no influence from the supplier. Actually, if you want a high influence from the supplier, let's just say this is a supplier that's been it's been there since the company started, organization started. You want to use 0. Because then you want to have a high influence from that supplier because it's your bread and butter, is where you receive the majority of your materials, and that's not highly unlikely going to change. But for this one, we're going to turn it off completely, even though we have the suppliers there, and we're going to see how that impacts our results. Okay, so literally no influence at this point from the suppliers. There you go. See how that looks. So obviously West Coast right by the DC, and then Northeast by the other DC, New York. So these are considered optimal locations based on the need. let me rename this to 2 plants with no supplier influence. All right, so if I was to go back to this one with no suppliers, they should be the exact same thing. Check it out. And obviously, because we're not using any supplier influence, so it makes sense that they would be basically the same. Okay, so let's try another type of experiment, the GFA experiment for looking for locations. So let's look for a factory using this CoView. I'm gonna show you how it looks. Here we could use the number of sites, but we could also use the service distance. We're gonna set it at service distance of 500 miles, meaning that you want to be within 500 miles of that factory satisfying that DC. So let's change that out to DCs, right? Because that factory is gonna satisfy that DC, put it in gold, and let's, I think we're gonna leave it at 50%. That's perfect, and we're just gonna change it to pieces, right? We want the results in pieces. And let's go ahead and run this model. And there you have it. You have 3 sites now, DC 1, 2, and 3. And just kind of show you how it looks. So in reference to the service distance, I know a lot of you guys, why would I use service distance? Well, it's very important when it comes to really from DCs to customers, but you could also make it very important from from the factory to the DC, because maybe you want to service your DCs at an appropriate time frame. This way, maybe potentially, so you could stay lean with your DCs, especially with your inventory. And maybe potentially, maybe you only have financial means to put 3 sites, right? You could select 3 sites and that's all you have. So this would be the optimal result for 3 sites. And so here you go is your DC1, satisfy these 2 DCs, and you would respectively set up one for the Los Angeles and one for Houston. So let's rename this 3 DCs, service distance 500. Perfect. And let's run one for 700, just for the hell of it. Go ahead and run it. There you go. 700-mile radius. So now about a day and a half of driving for a truck driver here, from here to here potentially, 700. And the other one is placed there, right on top of the supplier. So right up top. So only 2 sites on this one. So we're gonna rename it 2 DCs. Service distance 700. Perfect. Okay. So now that we have an array of options and scenarios we could select, I've showed you 2 ways to do that, and also with a sub decision of no supplier or with supplier influence. You could also see that we use population potentially to drive the number of population that we need in order to support the factory, right? The workers. Obviously, you need a population to provide quality workers at the factory. So that's very important. You don't want to put a DC where there's nobody, right? And the great thing about these experiments and the differences between them is that with roads, you're actually using, right? You're using roads, right? So while the other one is CoView, and it's more of a service distance perspective. Okay, so now that you know the differences, you can use both of them as options to find your locations. So let's go ahead. Now that we finally, let's take a look. Let's choose one. I'm going to go ahead and select this one. I think this is the most appropriate one. It's 2 plants with supplier influence. Okay, so we're going to use this, and we're going to convert it into a simulation because we're going to compare it to our baseline. So I'm going to right-click on the results, convert to a sim scenario. And voila, now we have a simulation of our baseline where we're coming and importing from China, Shanghai, and one with we're just onshore. So now we're going to compare it before and after picture, right? And that's what we want to do. So let's go ahead and make a few changes though, because obviously we came from a GFA. There's a few things we got to do. Now, I currently don't have any reporting, guys, so since I have to build a report, it would take about me 15 to 20 minutes, 30 minutes to maybe build something great, a great dashboard. So I'm not going to spend that time here. So I'm going to go ahead and import one that's already done with that, save you guys time. Here's my import. And as you see, it's identical to this one. It's just, you know, a few changes because I moved the suppliers around, but they're going to be identical. So let's go ahead and I'm going to remove this one. So, and we're going to use this one with done reports. As you see, we have our reporting done now for each one of our dashboards, and we have quite a few reporting tabs available now. All right, so let's start with renaming this. First of all, let's rename it, and I'm going to call it supply chain. Call it maybe network onshoring scenario. This way, everybody can identify it easily, right? When we compare, and we're going to exclude a few things. Because obviously we still have suppliers, a lot of suppliers that we don't need anymore, right? We decided to go with a few already. So let's just definitely exclude them now. And the reason why they're here is because you could potentially manage your suppliers as you see fit, right? So before we deleted it, now we're just going to exclude so we could potentially maybe use other suppliers if we need to in our scenarios. But for right now, I'm just going to undecide. So we're going to keep this supplier here, supplier 5, and this one from Montgomery, right, which was chosen for this factory. So 5 and 3 we keep. And I'm just going to exclude the other ones, and they're going to be grayed out, but still available if you want to use them later on, right? So this is kind of neat, a nice way to continue managing your suppliers and selecting and viewing what works for you. Now, next step is when we converted over, these are still sites, and we want to be able to allow these sites to convert. So when I'm talking about our plants, we want to create them and make them factories. So let me select, right click, and convert to a factory. There you go. Now it's a factory. See that? I could also go here and change that as well. So let's just go here, and this time I'm going to change it in the table editor, and you'll see how this changes once I make that change. There you go. Perfect. All right, so now that we've changed those into factories so they can actually produce their finished product, we're going to go ahead and go to our DCs and factories, right? Always a great way once you're going from one converting to another component, just to kind of change the naming conventions, right? Does this feel good to you using these names? Also going to your groups, make sure you rename groups that you could easily identify with them, right? For example, if I go to my plants, right? Plant Houston plants, so I identify them as plants group, right? And the same thing with customers and supplier groups, right? Here's my supplier group if I ever want to call it out, and just kind of helps me later on manage my records and data whenever I see fit. So it's just an easy way to make your work a little bit easier. Okay, so now let's go ahead and import some data from our baseline, right? We want to compare apples to apples, and so I'm going to bring some data in just to make sure that we're using the same things that we need to. Not all of it, but some of it. So let's import from our baseline here. Yep. And we're going to import, let me see, vehicle types. Yeah, we want to use the same type. We're also going to import maybe our facility expenses. So let me get back in there. There we go. Great. So let me import those two. Select where I'm going to import it in, onshore scenario. Click OK. And let me see. Oh, there we go. Vehicle types. So now we have vehicle types and we have facility expenses. We no longer need the carrying costs from the port. The port's gone already in our scenario, onshoring scenario. But we do need to add the plant, right? We have plants now. So let's go ahead and find my plant group. There you go. And let's make sure there's a carrying cost, other costs being anything from like utilities, stuff like that. Facility cost would be your rent. We're going to be renting these locations, all right? Now, for those that are looking to purchase locations, obviously there is another way. There's you could instead use initial cost, right? And you could say how much the cost is of the purchase of the building, right? It's a one-time fee. So let's go ahead and make sure our facility cost is set at something like 12. So for a day, a cubic meter, it's $12 a day per cubic meter. That's something we're gonna associate to our rent. It's a fair, I think that's pretty fair. And then we're gonna choose 250, kind of replicate what we have up here. But being that this is a plant, obviously it's not a warehouse. It can be, obviously, but for certain reasons, we're gonna just make sure our carrying cost is a little bit more expensive. So I'm gonna set it up at 15. Space is a bit valuable at plants. Obviously, warehouses is all about storage, so they were cheaper to have stored there. So this makes sense to me. Let's go to pets. And in pets, we're just gonna make sure that we associate the right pricing per mile between a location. So when I talk about going from supplier to DC, I wanna have that set up. So right now I have a supplier group to sites group, which is okay, but sites includes all sites. So I just want to include DCs, right? So between supplier to DCs, I put a 1.2 cost per mile based on volume. So now it takes in consideration that. And I'm going to choose a truck. Truck has more capacity than a lorry. And I'm going to use FTL. And then from DCs, right, we want to kind of go in that order now, right? Kind of tell the story. Supplier to DC, DC to actually, you know what? Let's make that change because we actually want to go to plants, right? Supplier to plants. Almost actually make that change. We want to go to our plants group, right? And then plants group, we want to go to DCs. That's the right order. And so this is the reason why I do that, because I can pick up on potential mistakes or errors and just fix it quickly. There you go. Okay, so here we're going to associate the same cost at 1.2. We're using the same truck, obviously, and also FTL. So we want to fill them up as much as we can since you're going between sites, and it just makes sense, right? And the next two, we're going to go to customers, right? DCs to customers, but we have two types of trucks available from the DCs, one with a higher capacity, one with a lower capacity to satisfy the needs. So we're going to go ahead and just make sure that we put DCs can deliver to any customers, right? And we're going to use product distance based as well still. But one of them, and we're going to go use roads, not straight. One of them is going to use the lorry, which is much cheaper and smaller capacity. And the other one, we're going to use a truck. We're going to try to do FTL here. And we'll see how well we're using capacity using FTL. Obviously, we could always optimize our transportation optimization to make milk runs as well. But let's just stick to just getting our factory set up. Okay, so let's put in here, let me see here. Let's put the cost of 1.8. Let's make it a little bit more costly. But let's make this the truck, right, a lot more costly because it has more space, so it costs a little bit more. There we go. And voila, our paths are set. So now we understand the cost and paths between and from a transportation cost, we're going to be able to get that. And let's go to our products. Now we need to add our materials, right? So our materials are going to be coming from our suppliers, right? So we want to be able to, I'm going to set that in pieces. We're not going to sell this materials. We just want to receive it at the factory to produce our finished good, but we are going to have to purchase it. So it's going to cost us about $19 per piece. So what I'm going to do here is that for every material package I get, it's going to be able to produce one piece of our product of finished good, right? So it's just a one-to-one. So every material package I get, I'm gonna be able to build one product. Now, obviously, you could definitely change this into tons, right? And later on, you could suggest, well, I only need a 0.005 of a ton to build a material. So you could later on, you could work with this, but just to make it easier for everybody to follow, I'm just going to use a one-to-one basis. So let's go to now to bombs. Let me look for bomb. There we go. Okay, so the bomb is just kind of like the list of materials you need to build your finished good, which is your product. That's your end product. And I'm going to build, I mean, I just need to build one, and just to build one, it requires my materials to be received, and I just need one of those to build my one-to-one, right, product. So pretty simple. All right. So let's go to unit conversion. So obviously that material also has a capacity. It takes a certain capacity from your capacity. In other words, it takes a certain storage or space from capacity. So let's go ahead and put materials in, and we're going to say that it was the same amount of space as our product. So we get something similar size from the material perspective, and we're building it, so it's going to be similar. So let's just say that 0.05 cubics. It's similar. All right. So now our trucks are going to understand how much they could carry. Now our warehouses are going to understand how much space it needs, and so forth. And we can start working with capacity levels, because maybe at one point, maybe a warehouse gets full, so it'll probably suggest, hey, we're full, we can't fulfill anymore. And so we want to create a realistic model, and so you need to definitely provide a unit conversion for that. Okay. Let's go ahead and now to one of our final steps here before we run our model. Let's go ahead and add production, right? We want to produce this, and producing this costs a bit of money. So let's look for production here. And we're going to say our plants, right? Our plants are going to produce this product. And they're going to use the BOM material so they can follow the ingredient list. And it's going to be cost of $15 per unit. So it's a pretty expensive unit for that product. And we're going to provide a rate. It's very important later on, because it's going to help us identify how much we need to store at locations, how much we need, and because it might be that the rate's too slow, so we want to have a lot more in early on and later. So what we're going to do is we're going to say about 25 seconds per unit. That's fine. Keep that in mind. Let's just say you're working with more volatile rates, then you could obviously make selections there and provide a more distribution type. For example, you could say maybe it could take anywhere from 23 to 28 or so, right? So you can use something like that. But for right now, we're just going to use something standard like 25 seconds, right? Okay, so last but not least, let's just go to our inventory. There you go. And so once you import from GFA, you'll get an actual levels to use, min and maxes. So it'll kind of be done for you, but because we're working with rates, we have to adjust these inventories, because now we've included rates, so maybe the inventory levels are not the same. So instead of spending the next 5-10 minutes figuring that out, running like a safety stock estimate or just trying to kind of get the right levels, I'm just going to go ahead and remove that, save you guys that time, and just import, my inventory from my completed one. So go ahead and do that. Yes. There we go. So now I found the right levels, and I'm going to put that into my onshore scenario, right? There you go. And voila, now we have a fulfilled scenario for onshoring that we could compare to our current baseline. Okay. Let's just make sure that these are set up to all products, right? Because now, because it's one-to-one, then it's perfectly okay to have all products, meaning materials and product are 1-to-1 levels. They should match, right? Because they're going to be, it's a 1-to-1 level. So this is perfect. Just do want to go back to sourcing and make sure that our plants do have, here you go, just kind of, here's another change before we start, is from our suppliers, just making sure that our suppliers are actually providing the material, not the product, to our plants. So there you go. That's it. Okay, so what we're going to do is I could go ahead and run this simulation like by using a quick run. And we could see the results. And I'm just going to say yeah, but the whole point is you can be able to see the results in comparison to what you had as a baseline. This is just a quick glimpse of it, right? You can see the results, but what we want to do is we want to compare them head to head. So let's go ahead and configure a head-to-head solution for this. I'm going to compare these two here, right? And I'm going to select a few things like costs to compare them with. And I'm going to select, let me see, facility cost, let me see, inventory cost, other costs, because we have utilities, production cost, stuff like that, total cost, and transportation cost. And we're also going to use service. We're going to select ELT, how fast and are we providing on time based on their expectation. Currently, the customers are 1 to 2 weeks, so I've selected 10 days estimation, right, based on the customers. And the service level by products is, did we have the inventory once they purchased, right? So two very important customer-focused KPIs, because we want to make sure that we focus on customers as well on our changes, right, going on shoring. Let's also look at spend. How much should we spend in purchasing those materials? Tariffs, right? We want to pick that up. We want to see how much it was. Profit. And let me see what else here. Revenue. And dropped orders. Let's see, did we lose customers? Obviously, this is going to be interesting, right? How well were we doing? So let's take a look at demand plays drop products by customer. I think this is going to be interesting. All right, so let's go ahead and run this model. This changes to pieces, running at 11 threads. Okay, we have about over 100 KPIs, guys, that you guys can select from utilization, vehicle capacity, you name it. So you could go head to head with these two scenarios and take a look at this. Here's our baseline and our onshoring. With our baseline, we lost about 7,000 products, right, that were dropped. So some lost revenue there. Well, here we didn't lose any. So facility costs, obviously we had more on the onshore, obviously, because we picked up the factories. Inventory carrying costs, here's obviously 1 million. So obviously this is a little bit higher. I expect a little bit the other way, but I'm going to find out. It's most likely because we service really well. So let's see a little bit later on. Inventory spent a little bit more. And other costs, production costs, no production costs when we imported, obviously. Here's our profit. Big difference. Revenue, obviously because we lost some products along the way. But yeah, look at this service, just this little bit of a difference when we're talking about millions of products, right? Just that enough is basically good enough to change the profit by that much, guys. Here's tariffs, 4 million. And total cost, big difference, right? There's more cost of the onshoring, but look at the transportation costs, huge difference. We basically almost went from double to half. So this is interesting results. Okay, so great way to view and understand at this high level how these scenarios impacted in your supply chain. So, but I'm sure a lot of you guys are thinking, well, that's not exactly what is happening. And you maybe want to replicate some of the current volatile changes that happen, right? Well, what I'm going to do is I'm going to import one with these events to kind of show you guys a bit of what we can do here, right? this is going to be really exciting. So what I'm going to do is I'm going to create certain quick events, and I already have them done for you guys. And I'm going to replicate what happened with COVID real quickly, so you can see what really happened and how that impacted what we currently had in case of what we would have had if we had something onshoring, right? So here is where we have COVID, right, 19 that happened, where we shut down our production lines. This happened February 3rd, where all suppliers were shut down in China, especially in the Shanghai, where all factories are located in the port. Then a week later, they closed the border. Then they opened it a month later, so big difference. And then on that same day, they opened up the production line, right? So obviously, basically 1 month of no production, of no sent shipment. So let's see how that impacts us. But on top of that, we're going to also impact the production lines, right? Once we come back up, because we didn't go up 100%. So what I decided to do is I made this a factory. Obviously, it's a supplier, but we ran it, before we were running at 12.5 seconds per product. Now we doubled because we lost half the production rate. So now it takes twice as much to build one product, right? Because we don't have all the labor force up there. Maybe we're at 50%. But here's where you see we gradually start getting back to normal up to this last month in Shanghai. So I'm trying to replicate the production issues they may have encountered and see how that impacts us going forward, right? All right. So I'm not gonna go ahead and run this model. It's already good, but what I'm gonna do is I'm gonna compare all three now. Right. And we're set up pieces. There we go. And so obviously, you know, the obstacle here is that obviously doing this in a spreadsheet is virtually impossible. It would take too much time. And so what we're doing here is we're showing you an effective and efficient manner to do this, to basically compare all scenarios, right? From your previous supply chain to your current supply chain with volatile events, and finally our future onshore supply chain that we just currently optimized and now we're simulating. So let's take a look at the results. All right, look at our current volatile baseline with the COVID, right? Big impact. Inventory carrying costs like much higher. Obviously, we didn't really produce. This is more of a supply, but we did it to impact the supplier. So it is more of a supplier spend of purchasing the product. I just want to call that out. But here's the profit. Look how much, where are we at? How much we lost. This is insane. So if you were onshoring, you did really well potentially this year, right? If you had materials and all that to continue building your product and tariffs. And as you'll notice, the transportation cost was a lot more, well, because obviously we were not at full stand production wise. So I'm assuming that a lot of the vehicles weren't full. So we had to provide more vehicle just utilization, right? It was probably lower. And we could probably added that here as a column too to identify it wasn't really vehicle utilization. You'll probably notice that most likely it was. So really interesting storyline here, guys. So obviously the result will provide, this result's going to provide a quantitative high-level executive view to understand the opportunity, the impact to your customers, the risk and the trade-offs prior to implementing, and at the same time providing an effective and efficient way to strategize your onshore plans, and at the same time grow your organization's ability to make strategic decisions. Well, I hope you enjoyed today's demo on evaluating onshoring strategies. Now I'll pass it over to John.
Thank you, Alex. Sorry, I was just replying to one of the questions. So switching it over now. Okay, so AnyLogistics is an end-to-end analytics tool that helps organizations make data-driven decisions on their supply chain. It does this by helping you build complex models with a data-driven framework. While in the past, we had to build everything from scratch. It also includes GIS and demographic data to help go deeper in analysis. Finally, as we saw today, it allows you to create a digital twin of a supply chain so you can quickly run different types of experiments on your supply chain. To do that, you set up a scenario or a model in AnyLogistics and then perform an experiment. That might include greenfield analysis, network optimization, transportation optimization, risk analysis, inventory optimization, what-if analysis, and other scenario comparisons. And these experiments then give us results, which with a single click can be converted into a new scenario and new experiments. So this is how you capture the complexity of a real-world supply chain and make enhanced business decisions with any logistics. If you're making changes to your supply chain in 2020 and think any logistics can help, we have a few ways to get your team started. First, we invite you to schedule a private demo. If you're in North America, you'll schedule with me. And if you're outside of North America, you can find your local distribution partner at anylogistics.com. Go to anylogistics.com, company, and then partners. And if you want to schedule with Simwell, you can email me at jsantavi@simwell.io. If you want to use this tool or learn more about it, you should join our public training class that's scheduled September 22nd to the 25th. This is a great way to learn how to use the tool and even to evaluate the tool. We encourage you to invite others to see how any logistics can be used with your team. In the 4-day course, you'll learn how to solve end-to-end business problems in your supply chain with any logistics. Again, feel free to email me at jsantavi@simwell.io if you'd like to join it, and watch your email for a discount code for all webinar registrations in August. I'll be sending that here probably today or early tomorrow. And finally, we host private training classes. This is a great option if you're training a handful of people and you want customized attention. For more information on the private training classes, email me at jsantavi@simwell.io to set up a time for a private training. So thank you to everyone that joined this webinar. If you found it useful and want to learn more, please contact me at jsantavi@simwell.io or the website above, www.simwell.io. And we've reserved a little bit of time for Q&A. We answered most of the questions as they came in. I think there's a few more here. Is there a limit on the number of different SKUs you can create? Link from a production site. There's no limit. The more information that you're adding, it can impact runtime and speed and things. Sometimes it's a good idea to aggregate data or aggregate those, but there's no, I'm sure there's a theoretical limit. There should be no limitations that impact you from solving a business problem. One person said there's too much to learn in just an hour, wondering if the assumptions were not too many produced near real-time results. These are very complex supply chains and very complex problems that we're solving. So this is a lot to learn in an hour. We try to pack it in as best we can. We have to make some assumptions and jump over things. So if you want to dive deeper into it, again, check out our training class. And there's training classes all around the globe. If you go to anylogistics.com and then click on the resources tab, there's an events. You'll see all the different training classes available. And that's the best way to learn more about how to build these models. Where do your cost metrics come from, and can you customize those based on locality? Absolutely. So you build the cost matrix into the model. There's different ways to track costs depending on, so that you can accurately reflect your real world costs. So you can do that, and you'll learn that in the training class and any of the training classes that you join. All right, I think that covers most of the questions. If I missed any, I'll follow up with you after the webinar. We close it up. So thank you everyone for making time and joining. Thank you, Alex. Put a lot of time into putting this together. Feel free to reach out to us if you have any questions, and we appreciate your time. Thank you all.